Okay. So here we are calling this max value function with these arguments, as I explained it earlier, that this is the state that you are passing. This is the value of the alpha and the value of the beta, and you are calling this max value function. Okay, when you are calling, and after that, it will calculate all the things, then it will return some value here. That value will come here, that will be assigned to this variable v, and then return the actions into state with value v. So this v we are using here. Return the actions, return actions. So at this state, what are the actions available with this value? Return those actions. This is what this module is saying. And what is this max value saying? Okay, we are passing this state, and this minus and positive will be copied here in this alpha beta, and it will return what? A value, utility value. You will reach at the leaf node, it will calculate some utility value, and that value will be returned here. And then after that, here we are checking that this state is a terminal state. If it is a terminal state, then calculate its utility value of that state and return it. Okay. If this condition is false, then you will come here, v is equal to minus infinity. And then you have so this is the starting value of the v here only within this function. And then you have a for loop for each a in actions into state. So on some state, what are the actions available? How many actions? 2, 3, 4, what? This loop will execute for those number of actions. For example, here, for this node A, 3 actions are available: A1, A2, A3. So for node A, this loop will execute 3 times. Similarly, for node B, how many actions available? B1, B2, B3. 3 actions are available. For the node B, it will execute 3 times. Similarly for C, similarly for D. And now, so for each action on a state, execute this loop. So it will execute 3 times. So this A is representing actions, either A1, A2, A3, or B1, B2, B3, C1, C2, C3, D1, D2, D3. And then we have this function max for the max player. This max will return the maximum value from the values. Okay. So this has the parenthesis here and ending here. And between that, you will have some values. You will have 2 values, 3 values, 4, whatever. It will give you, this function max will give you the maximum value from all those values. Whatever the maximum, that will be returned, and it will come here in this v. And then you are comparing that this v is greater than the value of the beta, which is this value beta, or you are using here. If it is greater or equal, then return this value v. Otherwise, go to the next statement. And here in the next statement, you have the value of alpha from here and the value of v from here, and then max. From these two, what is the maximum value? That value will be copied here in this variable a. And these all 3 statements are with this for loop. This return is not. This return, the value of v is not. So when this loop will end for all 3 actions, then you can come here at this return v statement. And what this statement is doing, look over here, I skipped this for a moment. And here, this is the value of the v, which is this one, minus infinity, and the min value. And this min value is that function. You are calling that function min value. And then within that function, you are calling another one, result SA. What it means? You are at a state S, and when you will perform this action, which is this action, which you are using here in this for loop, when you will perform this action on this state, where you will reach, what is the result? That result would be a state. So that state will be returned here. And you are calling min value with the state, with the alpha and beta value. So min value, state will be copied here, and alpha beta value will be copied here. And you are moving from here to there, and maybe there to here again and again. So here state alpha beta returns a utility value similar to this one. And if your state is terminal, return the utility value similar to this statement. And then V is equal to positive in infinity, opposite to this statement, because this min value function is for the min player and this max value function is for the max player. Okay. So now you have the same loop that you have here for each in actions into state, what actions are available on the state. So this loop will again execute 3 times according to that previous figure. Huh? And then here you have the min, here you have the max, here you have the min, and it will return the minimum value. And then you have the same V here, which you have here, and you are calling the max value function, which is this function, with the same result as A, alpha, beta, you know what it is. And then after that, from these all values, you will have the minimum value here, and then you are comparing V greater than or equal to alpha. Here you are comparing with the beta, here you are comparing with the alpha. And if it is less than or equal, if the condition is true, you are returning V. Otherwise, you are taking minimum from beta and the V. Here you have the alpha and here you have the beta, because beta is the variable for the min player. And this function will return minimum. That will be copied here. So both the functions, this one and this one, similar, but their variables are different. If you have a max value, then your variable is alpha. And if you have a min value, then your variable is what? Beta. Here. So if you want to memorize it, then it's easy. But if you want to understand it, okay, general understanding is here. This diagram is giving you the general understanding. But now we are going to run this example over that algorithm slowly and steadily. So that's why now I'm going to remove all that drawing. And I am considering, okay, you can consider this picture. I am at root node A. And these are my actions A1, A2, A3. Huh? This is B1, B2, B3. This is C1, C2, C3. This is D1, D2, D3 according to that previous diagram. But it is not mentioned here. So now I am going to start from here. So my state is what? My state is A. And then we are going to call this max value function, which is this one. But my state is what? My state is A. And this is the value of the alpha, and this is the value of the beta, and I am here now. So A, here minus infinity, and plus infinity. This is for the alpha and beta. Clear? And now I'm going next. My state A is terminal state of the tree. My state A is this the terminal state? These are the terminal states, not this one. So this is not a terminal state. So this is not, so the condition is false. So I will go directly here. And here V is equal to minus infinity. So my variable V has the value minus infinity. And then this loop will execute. And then this loop will execute for each actions on that state. How many actions are available on that state A? On that state A, how many actions are available? 3. What are those? On that state A, 3 actions, 1, 2, 3, according to that picture also. A1, A2, A3. These 3 states are, 3 actions are available. So for this, I am writing A1, A2, and A3 are available. And so this loop will execute for these 3 actions. And then I am executing it for the first one, A1. according to DFS. And then what will happen next? Max, and the value of V is what? The value of V is minus infinity. Okay. The value of V is minus infinity. And min value and the result SA. Result SA. State is what? S is what? A is your S is state A. So you are at A and action is what? A1. So when on the state A, when you will perform action A1, you will reach at what? B. You will reach at what? B. So this will give you the B. This will give you the node B. Hmm? And then after that, what is the alpha, value of alpha? Minus infinity. And what is the value of beta? Plus infinity. Which is from here. Which is from here. I know that. Okay, now, so now you are calling this min value with these three values, this function, you are calling this with these values beta, minus infinity, and positive infinity. You are calling it with beta, minus infinity, and sorry for that, and positive infinity. You are calling it this min value. If I will do some mistake at some point, you have to identify that mistake at that point, because this is a little bit lengthy algorithm. So I don't want to go up to the end with that mistake. So, so this B minus infinity plus infinity, min value. And now here I'm checking terminal test and state, my state is now B. So B is a terminal node of the tree. B is not a terminal node. This node, for example, here, sorry, this is not a terminal node. Terminal node are these one. So then what? Condition false, and I will come here. V is equal to positive infinity. Okay, now this is the value of the V. This is the value of the V for this function only. And this is the value of the V for this function only, positive infinity. And now for each actions on that state, state is what? Now state is B. And how many actions are available? 3 actions, B1, B2, B3. 3 actions are available. So now if I will write those actions here, B1, sorry, B2 and B3, and I will execute this for loop for B1. And here, now the next statement, because these three statements are under this for loop. So then min, what is the value for V? Okay, this is the value for V is, okay, this is the value. Just tick mark, huh? This is the value for the V. And then max value. So basically, I'm calling this function again with the value, but I have to evaluate this inner portion first. Result SA, S is B. And the action is B1, and the action is B1. So when you will perform action B1 on the state B, where you will reach? You will reach here at this leaf node 3. So I am now giving it the name 3, huh? Just to as a shortcut. So I will reach where? 3. What is the value of alpha? Value of alpha is minus infinity. And what is the value of beta? Plus infinity. And these 3 values will go into this max value. So you are calling actually this function with the new value, 3 minus infinity and the plus infinity. You are calling this function with these new values. And when this 3 will go into it, now your state is 3, huh? Your state is 3. And the values of alpha, beta is still same, minus, plus, huh? And then here you are checking. Your state is terminal. Your 3 is terminal. Yes, it is terminal. Then return the utility value of that state. State is 3, utility value is 3. Okay, that 3 is given in this tree, 3, 12. Actually, we are using this tree. Okay, so these values are given. These values would be given to you, and 3, 12, 8, 2, 4, 6, 4, whatever. So this 3, so this 3 where I am, terminal 3 is terminal, yes, return the value. So when this max value will return this value 3 will come here. It will take the place, of this whole line, huh? It will take the place of this whole line. And I am saying it 3. Clear? So the value of V and the value 3. What is the value of V? Plus infinity. So what is the value of V? This one, plus infinity. Min. What is the minimum value between plus infinity and 3? 3 is the minimum. So then now the value of the V is now 3. Value of V is now 3. Value of V is now 3. And then here next, now you are checking 3 less than or equal to alpha. What is the value of alpha? This minus infinity. What is the value of alpha? Minus infinity. So 3 less than or equal to minus infinity? No, condition false. Minus infinity is lesser value. So condition false. So I will not go there and I will go to the next statement. And here, what is the value of beta? Beta value is plus infinity. What is the value of V? 3. So plus infinity and 3. What is minimum? 3. So then the 3 will become the value of beta. 3 will become the value of beta. Up to now, we are here. So now the value of beta is becoming 3. So that's why here in the tree, the value of beta is becoming 3. We are showing it here, okay? So the algorithm goes like that, 3, and then the values of beta is updated here. Is 3 now. Okay, now. So these statements under this for loop is ended, and then we will go again. We will go again to this for loop because first action is finished. Second action, B2. This loop will execute for B2 now. This loop will execute for B2 now. And here, what is the value of V? Now the value of V is updated previously, 3, huh? So, okay, I am saying 3 now. Uh-oh. Where is the eraser? Good. So now the value of V, I'm just writing it here. It is just to be, but it is the previous step. Okay, not that, but I don't have the space. So that's why. So, or you can draw something like that, huh? For easiness, huh? So the value of V is 3 now. And then max value. I am here for the action B2. Max value, result. Now, result, my state is what? My state is still B. And then the action is B2. Then the action is B2. Where I will reach with B2? From B, action is B2. From B, action is B2. From B, action is B2. Where I will reach? 12. I will reach at 12. So I will reach at 12. Now I will making shortcut. Okay, I will not write all the things. I will write all the things in my mind. Okay, so you have to be with me. Okay, so result as state is what? 12. So I from this portion I will have 12. And now this 12, okay, for just one step, this 12 and the value of alpha is what? Minus infinity. And value of beta is what? 3. Good. This will go into this max value and we will call this max value with these with these new values, with these. Okay, I don't think so. We have to draw this. So 2 minus infinity and then 3. So now we are calling this max value with the value state. This is not 2, 12. So 12, it is a terminal state. Yes, return the utility. Okay, 12 is the utility, and then you are coming back, and then this whole statement is giving you what? 12. It is giving you what? 12. And then what is the minimum between the V and the 12? V is 3. 3 and 12. What is minimum? So between 3 and 12, this min will return the minimum value. So then 3 will be returned, and the value of V is still V3. And the value of V is what? Still 3. What happened? We are just in the beginning of this algorithm, okay? Still, we have to travel a long journey, huh? We are on the first node. Okay, I will give you this algorithm. Okay, so that you will pray something good for me. Anyhow, so the value of V is still 3. And now we are checking 3 less than or equal to alpha. Value of alpha is what? Minus infinity. 3 less than or equal to minus infinity? No. 3 less than or equal to minus infinity is lesser value. 3 is positive value. Huh? So 3 less than or equal to minus infinity? No, condition false. You will come to the next. Beta, what is the value of beta? 3. Value of beta is 3. What is the value of V? It is also 3. So from 3, 3. So both are 3. So both are 3. And then what is the minimum? 3. So the value of beta is still 3. So after opening up the second branch, min player has not accepted the 12 value. Huh? After opening, so if you will look here, after opening this 12, this is the min player. Min has not accepted the highest value. Still the value of the beta is 3. Still the value of beta is 3. Now for the last action, B3. We will go again for the loop and B3. And here value V is what? It is still 3. Max value, result, S is B, capital B. Huh? S is B, action is B3. When you will perform this action, where you will reach? If you will look into this picture, you will reach at 8. You will reach at this 8 node. So this inner portion result SA will give you what? It will give you 8. And the value of alpha is what? Still minus infinity. Value of beta is what? Still 3. 8 minus infinity and 3. Okay, now 8 minus infinity and 3, you are calling this max value, this value. When you are calling with this 8 or something like that, I'm not going to write it now. And then state 8 is going into it. 8 is a terminal test. Yes, it is terminal. Return that. Okay, this value will be returned and 8 will be returned. 8 will be returned here. And now what is the value of V? 3. And what is the value from this whole statement? 8. So what is the minimum between 3 and 8? Still 3. So the value of V is still 3. No update. So min player is not accepting that higher value. And then you are checking this 3 is less than or equal to alpha. Alpha is what? Minus infinity. Condition false. You will come below. And the value of beta is already 3 previously. Value of beta V is 3, 3, 3. Minimum is beta is 3. So after opening third branch, the value of beta is still 3. So here, when after opening a third branch, the value of beta is still 3. Still 3. And now, so now this for loop is finished. Hmm? When this for loop is finished, then return the value of v, which is what? 3. So we called this min value here with these values. I'm not going to draw something next. So we called this b minus infinity. We call this main value. So this was the previous call. This was the previous call. And now when we call this mean value, all happened and it is returning what? It is returning what? 3. It is returning what? 3. So min value, this whole statement is returning what? 3. So what is the value of this v? This one, minus infinity, huh? Which is written here, minus infinity. So minus infinity and the 3, which is maximum? 3. 3 is maximum. So the value of v is now becoming 3 here. Value of v is now becoming 3 here. And now we are checking. 3 greater than or equal to beta. What is the value of beta? This positive infinity. Plus infinity and this 3. 3 is greater or plus infinity is greater? So 3 greater than plus infinity? Condition. Condition. 3 greater than plus infinity? Condition false. 3 is smaller than plus infinity. Condition false. So then you will come here. What is the value of alpha? Alpha is minus infinity. And what is the value of v, which is 3? What is maximum? 3. So the value alpha is now becoming 3, which you are seeing here, at here and also here. This is the value of alpha. And the one branch is finished. Now, and this one action is finished. A1 is finished. And now this loop will go again for the action A2. For the action A2. And then, okay, we are going again into it. Value of v is now updated. So I am making this arrow so that I will not do the mistake. For A2, min value. Now, result S, my state is what? My state is A. And on A, when I took action A2, where I will reach? I will reach at C. When I will take this action A2, I will reach at C. So this result SA, it will give me C. It will give me what? It will give me C. And then value of alpha, you have to take care. Value of alpha is updated. So that's why 3. And what is the value of beta? Look over the whole function. What is the value of beta? Okay, that is plus infinity, I think, if I'm not wrong. So this is now, so min value, we are calling the min value function. We are calling this function again with these values C3 plus infinity. We are calling it again with C3 and plus infinity. We are calling this. This one is finished. C3 plus infinity. We are calling this main value again. Okay. State is C. Alpha value is 3. Beta is plus infinity. And we are checking C is terminal. No. And then we are going next. V is equal to plus infinity. V, what is the value? Now it is again value. What is the value of V now? Plus infinity, because it is coming again, huh? So maybe I have to, if it will work. Yes, Alhamdulillah. Yeah. So I am removing all that stuff because that is not needed. This is a new call. The things which I can easily Remove that would be good for me. Okay, I don't know. Either I have to remove them or not. This is the previous one. I will write them in a new way because it is taking time. So anyhow, so C3 plus infinity. So now the value of V is plus infinity. Node is C for each action. So now this is not needed. And I have new nodes C1, C2, and C3. And I am going to execute for the C1. And after taking this action, so min V max value result SA. So S is C, and from C, I'm taking C1, the action, and where I will reach, if you will look into this picture from C, if you will take C1, you are reaching at 2. You are reaching at 2. So you are reaching at 2. So I am saying that I don't need that. And I am drawing a line here. And where I will reach that, I will reach at 2. And the value of alpha would be what? Value of alpha is 3. Value of alpha is 3. And the value of beta is what? Plus infinity. I'm looking here. So that's why. From these values, value of alpha is 3, value of beta is 3. So I have updated those values here. And this, we are calling this max value, and this is 2, and this value of alpha is 3, value of beta is plus infinity. And I am calling max value this function with state 2. So this state will go into it. This state is a terminal. Yes, it is terminal. So return its value. Its value is 2. So return that. So it will return this value back here. This will return this value back here. And then value of V is what? This is the value of V is positive infinity, plus infinity. Value of V is what? Plus infinity. And the value of this whole statement is what? 2. So what is minimum? 2 or plus infinity? 2 is minimum. So the value of V would be updated with 2 now. And then we are checking 2 less than or equal to alpha. Alpha is what? Alpha is this 3. Alpha is this 3. So 2 less than or equal to 3. Condition true. Condition what? Condition true. 2 less than. 2 less than equal to 3. Condition true. Here condition is becoming true. When it is true, return V. Return mean go out of this. Go out of this algorithm. Go out of this function. It means skipping the next 2 branches. Skipping the next 2 actions. We are not going to perform these 2 actions. We are returning. We are what? We are returning from this function after looking over this condition. So this condition is responsible to provide you that filter, provide you that filter. So 2 less than or equal to alpha, condition. This value of V value is when the value is becoming less than alpha is something trying to get maximum value. So when this V is less than or equal to alpha, condition true, because 2 is less than 3, then return V. So we are returning the value V. When you are returning this min value, you are going out of this min value function, which is here. And here you are returning value 2. Because this was the call previously. This was the call to this min value. How many students are understanding this algorithm? Just raise your hands. This is quite a good number, huh? Alhamdulillah. How you are understanding the last one, Zohair? You are looking down, maybe on your phone, huh? Anyhow, Khalli Walli. This is a very good Arabic word, huh? Khalli Walli. In the whole language, this is the beautiful word that you have, huh? Anyhow, because I have now half of the journey is done, half is remaining, maybe more than half is done, because skipping was the procedure here. So I don't want to do talks with you, and maybe I will forget something. So anyhow, 2, this will return the value 2 here. This will return the value 2 here. And now you have to, so this main value that you called here, that whole statement is returning what? It is returning 2 here. And now what is the value of this v? This is 3. So 3 and 2, 3 and 2. What is maximum between that? 3. 3 is maximum. So 3 is maximum. That max player will, so still the value of v is 3. We are not using that 2. We don't need that. Anyhow, but check it here. So this 3 is greater than or equal to beta. What is the value for the beta? Value for the beta is plus infinity. So 3 greater than plus infinity. No, condition false. Then you will come here. What is the value of alpha? Value of alpha is 3. Huh? Here, the value of alpha is updated also here, not minus infinity. Okay. So that's why the value of, this was the previous value written here. The value of alpha is 3 and the value of v is 3. So from 3, what is maximum? 3. So still the value of alpha is 3. Still, this, how we filtered out these branches. So for example, here, when you have seen this 2, so value of beta is becoming 2. And then in the next step, it filtered out all these branches. It filtered out all these branches. In the next, actually, this is the step. Filtered out not all these branches. And then we are going next. This is the next, not yet, not yet. Leave it, leave it. We are here. In this diagram, we are here. So the value of alpha is 3 now. And now we are going to execute the A3, which is the last action. We are going to execute. So what is the state? State is A. State is A. Action is A3. From A, when you will perform action A3, when you will perform action A3 from A, you will reach at D. And here you will have further actions D1, D2, D3. So we are performing this A3. So from this state A, when you will perform this action A3, where you will reach? You will reach at D. And what is the value of alpha? Value of alpha is still 3. And what is the value of beta? Previously it was beta. Beta, it is not updated anywhere. Plus infinity. Plus infinity. And we are here. Okay, so now min value, we are calling this min value, this function again, with the value d3 and plus infinity. We are calling, so this is now finished. And now we are going to consider it. Okay, I don't want to write it. Okay, that is near, huh? That is already near, so I'm not writing it again. But if you are insisting me, then I can write them again, but not needed actually. So now this is the input to this min value. Your state is D. This is the alpha beta values. And then here you are checking D is terminal. No, then you are coming here. Then you are coming here. Okay, I can remove. This is also not needed. Maybe this is also not needed. Okay, this was the previous calls not needed. So now V is plus infinity, huh? V is plus infinity. And this loop will execute for what? Small d1 you can write if you want. D1, D2, and D3. Okay. So now I am executing it for D1. Min, what is the value for V? Plus infinity. This is the value. Max value result from D, action D1. when you will perform action D1, where you will reach? We will reach at 14, action D1. So 14. So here, this portion will give me what? 14. And what is the value of alpha? Where value of alpha is 3. And what is the value of beta? Plus infinity. Okay. Now these three values will go, we will call this max value function with these three values, 14. When you will call it, 14 is a terminal, it will return the utility value, and this 14. So this statement, when you will call it, it will go there, and this function will return 14. This function will return 14. So now what is the value of v? Plus infinity. And what is this value? 14. So plus infinity, what is minimum? 14 or plus infinity? 14 is minimum. So the value of v is for now 14. And now 14 is less than or equal to alpha. What is the value of alpha? 3. 14 is less than or equal to alpha? 3. No, condition false. You will come here. What is the value of beta? Value of beta is plus infinity. Value of v is what? 14. So plus infinity and 14. Plus infinity. Beta is what? I am just writing for your easiness. And v is what? 14. What is the minimum between these two values? 14. So the value of beta is now becoming 14. So now it is updated. So just have a look over it. When this 14 is opened, value of beta is 14. Similarly, so now value, and then it will go for the D2. And if you will look over this picture, what is next? 5, and then D3 is 2, 5. So then you are going to for the action D2. And what is the value of V? Value of V is what? Value of V is now 14, not plus infinity. Okay, remember it. And max value result, when you perform this on state D, when you perform D2, you will reach at what? 5. You will reach at 5. 5. What is the value of alpha? 3. And what is the value of beta? 14. So this is now you are calling the max value function, this function, with these values, and your state is 5. State is terminal. Yes, it will return the utility value. And what is the utility value? 5. So that 5 will be returned here for this whole statement. So it will return you 5. And V is what? 14. And this is giving you what? 5. So which is minimum? 5 or 14? 5. So this value will be updated as 5. And now this is gone. And now then you are checking V less than or equal to alpha. Alpha is what? 3. 5 less than 3. Condition false. You will come here. What is the value of beta? That is previously. Okay. So previously it was value of beta is what? Previously 14. And value of V is what? 5. So what is minimum? 5 is minimum. So this is not needed. The value will be updated. So the value of beta is 5, which you are seeing. It is not given here, skipped. It is now directly going to this 2. And now for the last D3. For the last D3, when you will perform this D3, you will reach at which node? This 2, this 2. So then you will call it with 2. Value of alpha is what? Value of alpha 3, I think. And the value of beta is what? This 5. So you are calling this max value function, which is this one, with these 3 values, 2, 3, 5, which is the state, alpha, and beta. This state is a terminal. So return the utility value, that is 2. So this value will be returned here. And then you will have 2 here. So what is the value of V? V is 5, 5 and 2. What is minimum? 2 is minimum. So then this is not needed. Value is updated with 2. So value is updated with 2. And then you are checking 2 less than or equal to alpha. Alpha is 3. 2 less than or equal to alpha. Alpha is 3. Huh? 2 less than or equal to this. This is the value of the alpha. And then V has this value 2. 2 less than or equal to 3. Condition true. Return this value of V. Return this value of V and go out of this main algorithm. When you will return, this value will come here, I think. This is 2, huh? This was the call. This was the call for this A3. Okay, now check this. What is the value of V3? And what is this value 2? So 3 and 2. What is maximum 3? So the value of V is still 3. No update. And then 3 greater than or equal to beta. Beta is what? Positive infinity. 3 greater than plus beta. No, condition false. You will come here. What is the value of alpha previously? 3. What is the value of V3? 3, 3. What is the maximum? 3. So the value of alpha is still 3. So the value at the root, final value at the root is what? Final value at the root is 3. Beta is also 3. This is which you are seeing here. There is an update only up to this point, but not here at the root. But not here at the root. This is the complete running of this small example over it. And if I will give you this example, and if I will give you this, okay. So now the properties of alpha beta pruning. So as we said that this alpha beta pruning is similar to the minimax algorithm, except this condition of filtering. Except only this condition is extra in it, which is filtering out or pruning the branches of the tree. So all the properties, which is completeness, optimality, space, time, all have the same. All have the same as minimax algorithm, except, sorry, for this time execution. Why time execution? Because you are filtering the branches out, so you are not wasting the time, huh? So that's why it will take less time. So that's why time complexity is much better. Is much better than all the other than the time complexity of the minimax algorithm. And then what would be the worst order for this alpha beta pruning? If think over it, now you have the understanding of this algorithm. Now think over it. What would be the worst case? When you are not removing any branches of the tree and you are considering all the nodes and all the branches, there is no any pruning in your algorithm, then this would be the worst order, huh? And then it would be like minimax. Then it would be like your previous algorithm. And then the time complexity would be order of b raised power m. And what would be ideal ordering? There is a worst case, there is an average case, and there is another thing for the complexity which is called best case. This is that ideal ordering. What is the ideal ordering? When you have your solution on the left hand side, because it is depth first search, or after that you will prune all the half of the, if you have your solution on the left hand side, it means from the root node you have your solution on the left hand side branch, and not on the right hand side, huh? It means half of the tree is now filtered out. So then the time complexity would be what? Maximum. What is the maximum branches? Divided by 2. Half of the tree. And now this is another example, alpha beta pruning. And this is the last class of your week, huh? Of this week, huh? This is your last class. You don't have any class. So then I want to finish it. Okay. Just give me some time. I am feeling cold. I'll make it on. I have the time. We have a time up to 1, huh?
Yeah.